Can I ask Dirk Martin, a Chief Sales Officer at MarinePaq, is that how you pronounce it?
Correct, yeah.
Yes, MarinePaq, to join us here. You will tell us a little bit about the interesting technologies that are available. So please, let's see now. Yeah, we just pull this one out.
This one out.
It should go, if technology works.
Famous words, should. How do I make this bigger now? There we are. Thank you, Johan, for the short introduction. Yeah, my name is Dirk Martin. I'm representing MarinePaq. I'm a co-founder and in charge of sales of this pretty young company in Luxembourg. And I just can congratulate the organizers of this conference for the very interesting presentations and speeches we had this morning. We were coming from the politics, from organizations, from institutions, to research institutes, down to the shipping industry, and now we come to a solutions provider or an equipment provider. We're coming down to a very concrete example of how we could contribute to shape the future of the Baltic Sea. So who are we? Who we are? As I said, very young company. We offer total solutions, a one-stop shop for addressing the water treatment in general, but very difficult waters to treat in particular. And here in this context, I shall be talking about the latest product we have in our portfolio, which is the MarinePaq, but I shall come to that later. We treat scrub water. I don't know if many of you here know what scrub water is. It's often confused with ballast water. That's not what it is. Scrub water is the water that's produced on board of ships when those ships, they use heavy bunker oil. The one Frederick mentioned, very high sulfur content. And in order to enable those ships to continue using this kind of fuel, which is quite cheap and very attractive, they have to install scrubbers to reduce the SOx and NOx emissions. So you see on the right-hand side the beautiful scenery which was commonplace many years ago. But thanks to scrubbers, we have ships like the one on the left, which basically just emit vapor. And this water is basically the seawater which is collected and is sprayed into the exhaust gases of those ships. So beautiful. We have a very good solution. The air is clean, but we end up with a water which is very, very, very contaminated. And this water, this is just a working principle of the engine, and then you see the scrubber, which is typically installed in the chimney, and this scrubber takes out all the hazardous substances from the water, but that needs also to be treated. Now, we saw in the earlier presentation, we saw this map already. There are some ECA areas, emission control areas. Some talk about SECA areas, sulfur emission control areas. The Baltic Sea is one of them, the North Sea and the coastal areas of North America. And in these areas, those ships, they have to have scrubbers on board, otherwise they cannot sail in those waters. So what are the challenges with scrub water? Scrub water, first of all, contain PAHs, that's polycyclic aromatic hydrocarbons. So these are not burned fuel hydrocarbons which go through the chimney. They have heavy metals, very very easy to decompose. They go into the food chain because they are bioaccumulative, and they end up on your plate at some stage down the food chain. They have something which is called the COD. It's a technical term to describe the level of pollution of a wastewater. So very high values, 2,000, 5,000, when wastewater has something like 500 to 600, just to give an order of magnitude. It's got free and emulsified oils, the ones which have not been burned properly by the engines of the ship. Soot particles, they're very minute, very small particles, which are very difficult to separate from the water because they are too heavy to float to the top, so you can skim them off. They are too light to settle, so they're kind of in suspension in the water, and it's very difficult to get them out of the water. We are dealing with a challenge, a challenge because it's high salinity. Okay, in the Baltic Sea, the salinity is not that high, but because you recirculate that water, you concentrate it up, and the salinity increases. So the equipment we built to treat this water has to be compliant with a very high salinity degree. And then a big challenge is that by 2020, all European waters will have a limit of maximum 0.5% of sulfur in the fuel. And then by 2025, all the international waters will be like that. So yes, we welcome ship owners who are thinking ahead in producing ships with LNG, but there's going to be, at least for 20, 30, 40 years, there are going to be existing ships which are very difficult or very expensive to retrofit to LNG, so they will have to work with the existing fuel system. And that is heavy bunker fuel or marine gas oil. That's how scrubber water looks like, by the way, which today is being flushed out into the sea. So, treatment of this water, there's several options. One option is you're treated on board. There is an IMO regulation that regulates that, quite lax. It's not as tough as if you treat it on coastal areas. But the discharge is not allowed everywhere. And we are seeing signs that more and more countries are enforcing that it will not be allowed to be discharged in those countries either. Another option is you store it on board, and then when you come to a harbor, the ship comes to a harbor, it will discharge the water to a waste management company. They will take it to an industrial site, industrial wastewater treatment plant, and treat it there. Very high cost, by the way. Or you have the third option, which is to treat it exactly there where the ship lands, on shore. And here comes the MarinePaq, our latest product. So what are the benefits of onshore treatment? We can go into a very much more complex process in treatment of the water than we can on board. We have activated carbon, ion exchanges. I don't want to bore you with the technicalities, but we can guarantee a water which comes out at the effluent, which is far more cleaner than according to IMO regulations. As I mentioned before, some countries, they forbid ships to sail in their waters and discharge this water. So for those ships, or in those countries, the ships will have to somehow address that issue and treat it on shore. The equipment is highly automated, so it can be operated by very few people, and one operator doesn't have to be there full time. 2 hours a day would suffice. It's adaptable to evolving norms. That means if the regulation today is such, tomorrow will be tougher. We just add modules to this equipment, and it can then address the tougher emission regulation. Remote access control. This is commonplace nowadays in the industry. You can sit in your office and control that plant from wherever you are, as long as you have internet connection to it. And the environmental impact of this treatment is far, far, far reduced. It's orders of magnitude lower than the one onshore. Just to give you a quick overview between onshore and offshore, I don't want to go through all details, but you see that in the case of onboard, there's only 3 parameters which are checked to be in compliance with IMO regulations. And all the other ones you see on the right-hand side, they are addressed by treating the water on shore. So on board, every ship will, and you will agree with that, every ship owner wants to have as much space for paying cargo or for passengers or for other things other than some waste treatment equipment. So the space is very constrained, and this you don't have on shore. Our first installation we have up and running now. It's the first of its kind in the world, to our knowledge, which addresses an onshore treatment of scrub water to achieve levels that the water can be discharged into the harbor. As I mentioned before, 2 hours of work per day, and an operator needs to go check some chemical levels, see if there's any leakage, and then that's it. The plant runs by itself. We dewater the sludge at the end of the process, so the sludge is reduced in volume, and this is the only waste you will have to take to a landfill or to an appropriate disposal site, whereas before you had a huge volume because it was very liquid, the waste. And the treatment cost per cubic meter is far, far cheaper than if, as today, the scrub water is collected and taken to a disposal site. Just to give you an idea of how this plant looks like, we have made an installation in container for ease of transportation and not to be obstructive to the view on the harbor side. 2 containers, 40 foot, stacked on top of each other. And we have, at the end, we have a tank that's an activated carbon tank. Don't need to know about that, but it's part of the process. Another view from the top, where you see the core of the installation, which is here the membrane, ultrafiltration membrane technology, which we have perfected to address this application. And to give you an idea where that is, this plant today is placed in Gedser in Denmark, and you can see it's taking up a dead space under the gangway that serves the ferry that sails between Rostock and Gedser, Denmark. And it has a capacity of treating several ships, so there are several ships sailing on that line. So it treats the water of those ships. And not to get into too much details, but we managed to reduce the cost of disposing of that water by a factor of 4 when you think about the operation cost of our plant. Thank you very much for your attention.